Welcome back. Today we're going to be talking about scientific notation. And hopefully you've seen scientific notation before. If not, scientific notation is just a system in order to express either numbers that are really, really, really big or very, very, very small in a more compact form. And it's composed of number is composed of two parts. It's the part out in front, and then a power of 10 raised to some exponent. A couple things: when a number is larger than 1, and if you put into a scientific notation, the power of 10 is positive, and a number smaller than 1, when it's put into scientific notation, the power of 10 is negative. Now, so here's a couple examples up here. Here, this number 1.39, 1,392,000 kilometers can be expressed inside notation as 1.392 times 10 to the 6th. So basically, in scientific notation, you're moving the decimal place, which is soon to be here in this number, and you're moving it either to the left or to the right until the only number right in front of it is a 1 through 9. And there's only one number on this side of it. So basically, on this number, you number 1, 2, 3, 4, 5, 6 spots until you have a single number between 1 and 9 that remains to the left. And so you just count up how many spots that was. 1, 2, 3, 4, 5, 6. And that's where that 6 comes from. Likewise, over on this side, this is a number smaller than 1. And to put this in time notation, right, we need to move the decimal place either to the right or the left. And I just mixed that up, first from the left and right, until the number in front of it is a 1 through 9. And there's only one of them. So right here, that's a 0, so that's not work. So I'm going to be moving it this way. 1, 2, and then finally a third spot right there. And now if I move it over 3 places, now this 2 is on to the left of the decimal place. And I moved it 3 spots, and it's to the right. That's why it's a negative 3. So it's positive if you're moving the decimal place to the left, and it's negative if you're moving to the right. In scientific notation, the part in front of the exponent, all those numbers are significant, so we have to keep that in mind. So if we look down here, this value here, 21.450, put this in scientific notation. I'm just going to move it 1 spot to the left, and it'd be 2.1405 times 10 to the first. Right? In this case, did scientific notation save us much space? No, it didn't. So that's why typically you're going to use scientific notation if something is really, really large or really, really small. The second example, all right, it's a number smaller one. We need to move this decimal place until the number immediately to the left of it is between 1 and 9. So it's 1, 2. So it'd be 2.00 times 10 to the minus 3. This value here, the decimal is implied to be here. So it's 1, 2, 3, 4, 5. So it'd be 3.45 times 10 to the 5th. Now remember, we only keep the numbers that are significant in scientific notation. You notice, as written, this number, these 3 zeros are placeholders, so they don't get included. Whereas these 2 zeros were significant, so they stay there, but these zeros in front, placeholders, they disappear. Over here, 1, 2, 3, 4 spots, so it'd be 3.0405 times 10 to the minus 4th. This number here, decimal is implied to be here, so that's 369. So this would be 5 times 10 to the 9th. And finally, this one, 1, 2, 3, 4, 5. So 7.50 times 10 to the minus fifth. Okay, so that's going from a value to scientific notation, and now we want to be able to go from scientific notation back to the numbers. And you will see, scientific notation written either times 10 to the fifth, or, your calculator may say e to the negative 5, and that is basically means 3.00 times 10 to the minus fifth. So this and this are the same notation. Just depends on what type of calculator you're using. So in this case, this number here, 3 times 10 to the negative fifth, if I am trying to take that out of scientific notation, I've got there, draw some zeros out in front, and I need to move it, since it's a negative 5, I need to move it 5 spots to the left. So 1, 2, 3, 4, 5. So that would be 0.0000300. Right, so remember, if the numbers are really, really small or really big, scientific notation makes a lot more sense. Going to this next example, 5.03, and let's put a bunch of zeros over here. 1, 2, 3, 4, 5, 6, 7. All right, so 0.000000503. This next one, 9.1 times 10 to the sixth. Put a bunch of zeros over here just so I can count 1, 2, 3, 4, 5, 6. So it's 9, 1, so I don't need that one. And then 5 zeros. 1, 2, 3, 4, 5. So in here, 8.20 times 10 to the 0. Well, that is simply 8.20. Because anything raised to the power of 0 is 1. So 8.20 times 10 to the 0th power is just 8.20 times 1. Will this, again, this, you wouldn't really use scientific notation to do this, but 2.8 times 10 to the second, so we'll just go 1, 2, so it's just 298. And lastly, 4.923 times 10 to the minus 2. So that means I've got to go 1, 2. 0.04923. Again, we're keeping all the significant figures from the number here, and we're just the numbers in front. The exponent that times 10 to the minus fifth, or negative 7, that is not significant. Okay, now, combining what we were doing before with significant figures and calculations, and now we want to get a better idea of how to use your calculator. So here's a calculator, and if I want to put a number into scientific notation, what you're looking for is typically the double E key right here. Or, depending on your manufacturer, if you have Casio, it might be an EXP. Or on some Texas Instruments models that don't have a double E, then it's going to be a times 10 to the N, or times 10 to the X, or something like that. So in this first example here, 8.3, and it says times 10 to the third, so I hit double E, and 3. So on the screen here, on my calculator, 8.3, and then this right here is the times 10. So even if I just hit the equal sign, just so you can see what it looks like, it's like, yeah, that is 8,300, which is what 8.3 times 10 to the third is. And then since it's just multiplication, all I need to do is 4.1 double E to the 9. Do that. This is what you get in scientific notation, 3.403 times 10 to the 13th. And then we have to apply significant figure rules. Right, we're doing multiplication. And so that means we go to the least number of total significant figures. This value has 2. This value is 2. We have to round this to 2. So 1, 2. It's going to be rounded to 3.4 times 10 to the 13th. Go on to this next one. Same setup. Times 3.2 times 10 to the 4th. You notice the calculator didn't automatically put in sign notation for me. And, right, you can put this in scientific notation in your head, right? So here's my decimal. It's going to go 1, 2, 3, 4. So it's going to be times 10 to the minus 4th. And then we have to figure out how many significant figures. That has 3. This is 3. So we get to keep this as 3. So 1, 2, 3. So the 6, it's going to be 2.41 times 10 to the minus 4th. Now, your calculator will be able to put in scientific notation for you. On this calculator, right above the 5 button, there's an SCI. And so if I hit second function and then SCI, calculator has put it into scientific notation for me. And you see it's in scientific notation mode because it says SCI up here. If I want to take it out of scientific notation, here's my FLL button, which is floating. I just do second function 4, and it's taken out. Obviously, your calculator that you use may be different. So that's the importance of knowing how to use your calculator. Because the biggest problem people are going to want to do on the first day is, like, let's say if I'm entering this into scientific notation, people say 7.52 times 10 y to the x negative 9, and that is 3, 6. It's not really getting what needs to be done, and that was you're going to have to be really cautious about order of operations. So we'll do a little bit of this in class for practice as well, because it's very important that you know how to operate your calculator. We look at this, right? We're doing multiplication and then division, and you notice there's only one significant figure in all these, so we'll be rounding it to 1 at the end. And we're not mixing operations, so we don't have to take significant figures after each step. So calculator says 5 to times 10 to the 9th for that one. And look over here. 5.8 times 10 to the minus 7th times 2 times 10 to the 4th divided by 4 times 10 to the 6th. This has 2 significant figures, that has 1, this has 1, it's all multiplication division, so we can just round at the end. We're not mixing operations rules between addition, subtraction, and multiplication division. Have to round this to only one significant figure, and that's going to be 3 times 10 to the 3rd. Now this value here is where you're going to see if you know how to use your calculator or not. Because if you have the other style of Texas Instruments, you got to be careful. And you may see in a second. So if I do 8.7 times 10 to the 6th divided by 3.6. You should get around 3.6 times 10 to the minus 7th is the correct answer. Right? The most common incorrect answers people will get is 1600. And that is incorrect. If you get this, if you get 1600, then you have an order of operations issue with your calculator. And if you need some additional help figuring that out, please let me know. All right, so that will conclude this video.